Welcome to another key session on large language models, LLMs, and related technologies. These videos are designed to sharpen your knowledge and prepare you for interviews in today's competitive job market. Each video includes a free self-evaluation quiz, and for our interns, we provide exclusive Anki flashcards to help you master and retain these concepts effectively. Let's get started. Wishing you the very best in your learning journey.
Today, we're going to pull back the curtain on a piece of AI that you use every single day, probably without even thinking about it. Seriously, it's the secret sauce behind some of the smartest features on your devices. You know what I'm talking about, right? You're texting and your phone just finishes your sentence. It feels like it's reading your mind. Well, it's not magic. It's a really clever kind of AI that isn't just looking at words. It's understanding the story that those words are telling, step by step. And that right there, that's the whole secret. It's not just about processing information in the moment. It's about remembering what came before. This special network has what's basically a memory, this little bit of context it holds onto from one step to the next. Okay, so before we dive into how the network works, we first have to get our heads around the type of problem it's built to solve. And that all starts with the data itself. You know, not all data is created equal. Some things are totally independent. A picture of a cat is just a picture of a cat. But then you have other stuff where the order is absolutely everything. Take the sentence, "The cat ran into the house." The sequence makes perfect sense. But if you flip it to "The house ran into the cat," well, that's just nonsense, right? That's sequential data. Context isn't just a nice to have, it's the whole point. So how in the world do you get a computer to understand something like a story, where what happened last time matters? Well, you build a special network just for that job. And this is the hero of our explainer. It's called a recurrent neural network, or an RNN for short. And its entire reason for being is to handle data that unfolds over time. See, instead of just seeing every piece of info as a separate thing, an RNN links them together, understanding that what came before is crucial for making sense of what's happening right now. And this is why I absolutely love this metaphor. Thinking of an RNN as a storyteller just makes it click. I mean, to tell a good story, you have to remember the beginning to make sense of the end, right? An RNN is doing exactly that, but with data. All right, so how does this memory actually work under the hood? It sounds super complex, but the basic idea is actually pretty elegant. It all boils down to a simple little loop that just keeps repeating. So imagine this. The network gets one piece of information, let's say a single word. That's step one. Then, for step two, it takes that new word and mixes it with what it already remembers, its hidden state. This hidden state is its memory of all the words it's seen before. And then for step three, it passes that new, updated memory forward to the next step, ready for the next word. It just does this over and over and over, constantly weaving the present into its memory of the past. And this super simple idea, it's incredibly powerful. Yeah, it's behind your phone's predictive text, but it's also the engine for things like machine translation, forecasting the stock market, or even understanding your voice to turn it into text. Basically, if you have a problem that involves a pattern unfolding over time, an RNN is probably the tool for the job. But here's the thing. Like any hero in a good story, our classic RNN has a weakness. Its memory, as cool as it is, isn't perfect. And this is where our story gets interesting. The big issue is that its memory can be, well, a little short-term. When the sequence of data gets really, really long, we're talking about summarizing a whole book, not just one sentence, our little storyteller starts to forget things. Those crucial details from the very beginning, they just start to fade away. Now, this tragic flaw has a pretty intimidating name, the vanishing gradient problem. Basically, as the network is learning, the importance of those early pieces of information gets smaller and smaller with every step it takes. Eventually, their influence becomes practically zero. It's like our storyteller getting to the last chapter of a book and completely forgetting who the main character was from chapter 1. It just can't build a coherent long-term story. But you know the story doesn't end there. Of course not. Researchers saw this problem and came up with a brilliant solution. They didn't give up, they just built a better storyteller, one with a much, much better memory. Let's check it out. So on the one hand, you have the standard RNN. Simple memory, but it fades. On the other hand, you have the next generation, things called LSTMs and GRUs. And the game-changing innovation here is a system of gates. You can think of these gates like a super smart control system for the network's memory. They can learn what information to forget, what crucial details to protect and hold on to, and what to pass along. It's what allows them to have a true long-term memory. And that really brings us right up to today. With these much smarter networks, we're building AI that can understand incredibly long and complex things, which leaves us with a pretty wild thought, right? As these artificial storytellers get better and better at remembering our past, what kind of future are we going to ask them to help us write next? Thanks for tuning in to The Explainer.
Thank you for watching till the end. Don't forget to test your knowledge with the quick self-evaluation quiz. The link is right in the description. If you found this video helpful, please like, share, and subscribe to support the channel. And if you haven't yet explored our self-paced AI internship program, visit shogini.com for full details. Wishing you all the best in your AI journey.